What we are trying to do is build a robot that feels as human as possible, not just in how it looks, but in how it moves, responds, and carries itself. That is not easy because engineering and design don't naturally align. They each have their own rules, their own logic, and they often pull in different directions. So when we started working on the next generation of the iron robot, finding that sweet spot between mechanics and aesthetics became one of our biggest challenges. Our design process begins with a systematic breakdown of the human body. From that understanding, we built what we call a general-purpose humanoid design framework, a set of rules that guide how a robot's skeleton should be formed. We believe a robot's sense of life starts from the inside. So every part of the framework, from how joints are positioned to how linkages flow, is crafted to echo real human geometry. But structure alone isn't enough. To make the robots actually move like a human, we had to understand the body's biomechanics and identify the key pivot points that define natural motion. For example, the spatial relationship between the waist, pelvis, and hips is set strictly from human kinetic data. So movements like lifting the pelvis or shifting the hips no longer feel mechanical. They become smooth and natural.
After we built the robot's skeleton, we wanted to make it even more human, so we thought it should have muscles too. We tried materials like sponge and silicone, but none of them worked the way we hoped. Then one day, we noticed a lattice toy sitting on a teammate's desk, and it immediately gave us an idea.
The flexible hollow lattice structure had just the right properties for muscle behavior. It could stretch, compress, and release heat, much like real muscle. From there, we developed different lattice patterns for each joint and using softer materials in the area that take compression and more elastic ones where strengthening is needed. And this reduced internal resistance and made the motions feel more natural.
We also refined the inner surface of each joint, so the soft material fits tightly to the frame while leaving space for controlled flexing. For example, in the knee joint, when Aaron bends his leg, the design guides the compressed outer material inwards into the open calves, keeping the leg's shape smooth as it moves.
Once we solved the challenges of the bones and muscles, our focus turned to the body itself. We wanted Aaron to carry the rhythm and proportion of a human body, just like Da Vinci's Vitruvian Man. Take the hips as the sample. We wanted to have a smooth, natural curve, roughly perfect golden ratio. And the challenge was conventional actuators were too bulky and interfered with the body's curve. So our engineers provide smaller, lighter, and custom-fit actuators that allowed we dynamically adjust the proportions based on the actual human muscle structure. We managed to strike that golden balance between engineering constraints and aesthetics, even for a curve of just a few millimeters. We refused to compromise. That's what defined Aaron.
For a robot, skin is a system where structure, functions, and aesthetics are tightly fused. We mapped the body's functional zooms and engineered different knit structures to match them. And when the robot moves, this elastic, form-fitting skin moves together with lattice inside, keeping structures, surface, and motion in sync. To us, the skin is not just a covering. It is what allows the robot's structures, movement, and visual expressions to finally feel like one coherent, living form. With a structure that mirrors the human body, from its skeleton frame to its muscle layering and surface design, Iron presents a silhouette that feels almost indistinguishable from a real person. But the real magic happens in motion, from a silent standstill to a confident stride. It moves as if something alive is following beneath the surface, making that shift from stillness to life, feel almost effortless. For those who are drawn to shaping beauty with cold machinery, for those who dream of giving a robot a pulse of life with their own hands, join us on this journey. Let's push the boundary where engineering meets art and create the one who may one day truly understand the human heart.